Sahelanthropus tchadensis. Now, to really grasp why this discovery was so important, we have to look at the scientific world it completely turned upside down.
Chad site Choros Manala, located in the Jirab Desert of northern Chad, is central to understanding the origins of the hominin lineage, primarily due to the pivotal discovery of Sahelanthropus tchadensis less than 7 Maya in 2001. The prevailing theory had focused on the Rift Valley as the sole cradle for early hominin evolution. The presence of S. tchadensis in Chad thus challenged the assumption that the Rift Valley alone served as the evolutionary origin point.
You see, for decades, the story of human evolution was often called the East Side story. The whole narrative was built around the Great Rift Valley. So finding a potential early human ancestor way out in Central Africa, thousands of kilometers to the west, well, that wasn't just some minor update, it absolutely shattered the old map. It told us that the cradle of humanity was likely much, much wider, a more complex tapestry of environments spread across the entire continent.
And at the very heart of this scientific revolution is one single, truly remarkable fossil.
The fossil itself is a nearly complete cranium. It was given the nickname tchadensis, which beautifully means hope of life in the local language. It was found back in 2001 by a team led by Michel Brunet, and its age is an estimated 7 million years old. That places it right at the very dawn of the hominin lineage, incredibly close to that pivotal moment when our ancestors split from the line that would lead to chimpanzees.
Even its scientific name tells the story. Sahel is for the Sahel region of Africa where it was discovered. Anthropos comes from the Greek word for human, and tchadensis, that's just Latin for from Chad. So when you put it all together, you get the Sahel human from Chad, perfectly grounding this critical discovery in the place it was found.
So what is it that makes this skull so fascinating? It's this unique combination of features, a mix of traits, some of which are surprisingly advanced, and others that are still deeply primitive.
Let's start on the primitive side. Its cranial capacity was only about 350 cubic centimeters. Now, to put that into perspective for you, that's a brain size very similar to a modern chimpanzee's. This firmly roots Sahelanthropus in our shared ape ancestry.
And this is exactly why scientists often describe Sahelanthropus as a mosaic fossil. You've got these ape-like primitive traits, like that chimp-sized brain and a very heavy brow ridge. But then you have these more human-like or derived traits, a face that's flatter than other apes from that period, and, this is a big one, smaller canine teeth. This kind of mixture is precisely what you'd expect to see in a fossil that's right at that transition point.
Yeah, that point about the teeth. It's absolutely vital. You see, male great apes, like chimpanzees and gorillas, they have these large, almost dagger-like canines, and they're kept sharp by rubbing against a lower tooth. It's a feature we call the honing complex. Well, tchadensis doesn't have it. That reduction in the canines is a hallmark characteristic of the hominin lineage. It points to a major shift happening, maybe in diet or maybe even in social behavior.
The anatomy gives us even more clues about how it lived. The enamel on its molars is on the thinner side, which suggests a diet of softer things like fruit and leaves, pretty similar to what a chimp eats. And we can even start to paint a picture of its world. The other fossils found right alongside tchadensis, things like fish, crocodiles, and different monkeys, they tell us this wasn't the dry desert we see today. It was a lush environment centered around an ancient lake with forests nearby.
But out of all of its features, there is one that has sparked the most intense debate, one that carries the most profound implications, and that is the evidence that it may have walked upright.
Okay, to really understand this, we need to look at a very specific part of the skull called the foramen magnum. It sounds complicated, but it's really just a large opening at the base of the skull where the spinal cord connects to the brain. And its position is a huge clue, a direct indicator of how an animal held its head, and by extension, how it moved around. So think about it like this. In an ape that walks on all fours, that hole, the foramen magnum, is positioned towards the back of the skull. This makes sense for a spine that's mostly horizontal. But in tchadensis, it's different. It's positioned further forward, more underneath the skull. And that placement strongly suggests its spine was held vertically, with the head balanced right on top of the body. That is the signature posture of an upright bipedal walker.
The fact that we see this potential for bipedalism so early on, 7 million years ago, that places Sahelanthropus in a very exclusive group. It joins other early hominin contenders, like Auror and tchadensis from Kenya, which dates to around 6 million years ago. These are the fossils that tell the story of the very first steps our ancestors took on 2 legs.
Now, despite this compelling evidence, the position of Sahelanthropus on our family tree isn't a done deal. It's not universally accepted. The debate is very much alive, and it's really fueled by the nature of the fossil evidence we actually have.
The main counter-argument really zeroes in on the back of the skull. Some researchers point to the markings where the neck muscles would have attached. They argue that these marks look more like what you'd see on a quadrupedal ape, which might suggest it wasn't a fully committed, habitual, upright walker.
And the core of the problem? Well, it's what we don't have. You see, the evidence for Sahelanthropus is almost entirely that one cranium. Without any bones from below the neck, no hip bones, no leg bones, no foot bones, any conclusion we make about how it walked has to remain an inference, no matter how strong it seems. It's this lack of postcranial fossils that really keeps the debate going.
Due to fossil scarcity, the inclusion of S. tchadensis remains contentious. Some researchers argue that the ape-like muscle attachments imply it was still fundamentally quadrupedal, and this is what we expect. The evolutionary transition from great apes to hominin is not sudden. The transition happened gradually.